So here are the solutions to the Black Art of Factorising Christmas Special. So if you want to prove yourself worthy to be one of Santa, or is it Satan? Santa's elven mathematicians, you'll need to factorise these fully. They also might help with your upcoming mock exam. You never know. So first of all, we've got this little beauty. It's two terms. There's no squares, so it's not different to two squares. So the common factor is, of course, 1/3, although I suppose we could probably take 2/3 out actually, so 2/3 is the common factor. So it's 2/3 times x and 2/3 times 2, because 2/3 times 2 makes the 4/3. Okay, question number 2. Little bit of a catch you out question this, because it looks a bit like it's the difference of two squares. We've got the 25 square number, the squared, the 100, all square numbers. But unfortunately, it's not a minus, it's not a difference. So all we can do is look for common factors here, and you can see that 25 is the common factor. And so it becomes 25 times x squared plus 4. And if you are in any doubt, in fact it's always good practice to multiply these out, but if you'd done it as difference of two squares and you'd multiplied out, you would have instantly seen that you were sadly wrong. So let's go on to some of the other ones. X squared minus 16, now this is the real deal, this is the difference of two squares, so it's x plus 4 and x minus 4. And always worth checking, so x times x is x squared, x times minus 4 is minus 4x, 4 times x is plus 4x, and then plus 4 times minus 4 is minus 16, and you can see that those two cancel, leaving you with that. Okay, we've got another one here, this is another difference of two squares. Notice the minus is a difference, so it's 12y plus 9 and 12y minus 9. Incidentally, you could have put these signs the other way around. It could have been a minus here and a plus there. It really doesn't matter, as you will find if you multiply out. Okay, so classic quadratic here. We should be spotting these quite quickly by now, hopefully. We've got three terms nicely arranged, so it's just a plain old x at the front. That means it's one we can just do by looking at it. Okay, so we've got x squared is formed by those two. Now the 24, good idea to write down what you can do here, because we've got obviously 1 times 24, so that could be a 1 and a 24, it could be a 2 and a 12, it could be a 3 times an 8, or it could be a 4 times a 6. 24 is a horrible number, it's got lots of factors. So which one is it? Well, to decide which pair it is, we have to go to the 5. And the only one we can make 5 out of is the 3 and the 8. So it doesn't matter what order you put them in, but the signs do matter. So to get a plus 5, we're going to have the 8 positive, because 8 take away 3, that will give us positive 5. So it's x minus 3, x plus 8, and be paranoid, always check x squared plus 8x minus 3x minus 24, and of course you can see that those make 5x, but like I say, if you don't check you are asking to get it wrong, so make sure you do check. Now this next one, similar, it's a 3-term quadratic, so it's going to go into double brackets like that, and we start off with our x's, and then we think about our 48. 48 can be made by 1 times 48, 2 times 24, and you might run into a bit of trouble here, so it might actually be of assistance when you're doing this, if you've not got a calculator handy, to do a little prime factor tree. 2 times 24, and that is 2 times 12, and that is 3 times 4, and that is 2 times 2. And knowing all of these numbers can help in working out the many options here. So we've got 2 24s, so 3 goes into it because it's here, and 1, 2, 3, 4 3s, or rather 4 2s, 2 to the power 4 is 16, so it's 3 times 16, 2 times 2 times 2 times 2. 4 goes into it, fairly obviously, 4 times 12, you might know that one. 5 doesn't. 6 goes into it. I know 6 goes into it because I've got a 2 and a 3 here. And of course the 12 goes into it, so it's 6 times 8, 6 8's 48, and we're done there, we've got the lot. And all we need to go through is find which pair we can use to get ourselves a 13 with, and that's the 3 and the 16. Now it's minus 13, which means we'll need minus 16 and plus 3, and you can see that the plus 3 times the minus 16 is going to give you a minus 48. And again, check it. If you've done it yourself and don't check it, you deserve to get it wrong. Like me, I'm running a risk here. Okay, but hey, live dangerously. Unless, of course, you're doing a maths exam, in which case, don't live dangerously. That would be a mistake. Same thing again here. This is actually the easiest one of the lot because we've only got one thing to try here. There's only one way to make 1. It's 1 times 1, and it's both positive. Interesting, the mysterious disappearing one, and I'll check this one just for good form's sake. So we've got plus 1x, plus another 1x, plus a 1, and you can see the bits in the middle will make the 2x. So, there we go. Let's go on to the Grinch questions. I feel like I should change colour here. Red was big Christmassy, let's go to green, that's Christmassy, isn't it? Right, now, this thing here. 2 terms, 3 isn't a square number, but they both got 3 in them, so it's 3x squared minus 1. And you might be tempted just to leave it there, in which case you will have let me catch you out, because inside this bracket here is the difference of 2 squares. So not only does the 3 come out, but this turns into an x plus 1 times the x minus 1. And it's easy to forget the 1's a square number. 1 is a peculiar little beast. It's a square number, because obviously 1 squared is 1. 1 is also a cube number. It's lots of other numbers as well, actually. I believe it's a triangle number. It's a very strange number, number for all seasons. Okay, so you managed that one. Now on to this. Now, this is again a 2-term quadratic, but of course the astute viewer will notice it's harder because of the 2 here. Now, 2 is not too bad. There's only one way to make 2. It's a prime number. It's an odd number 2 because it's the only even prime number. So we've got 2x and an x. Now, the 5 is also not too bad because 5 is also prime. So this leaves us with 2 questions really. Is it a 5 and a 1, or 1 and a 5? And then what are the signs? And to be honest, if you can't figure this out fairly quickly, you're best off just having a guess and trying it, because the more of these you do, you will develop an intuition. So, my guess is going to be 5 and 1, and it's not really a guess, it's because I'm looking to make 3. And I know that if I put the 5 over here, it will be multiplied by the 2, which will give me 10, and then there's no way I'm going to get down from 10 to 3 using only the 1. So if I put the 2 and the 1 together, that gives me 2, then the 5 goes with this, and that will give me 5 and 2, and the difference is of course 3. Now it's a positive 3, so plus and minus, but again, don't be deceived by the maths teacher's easy patter. The only way to get to do these yourselves is to practice. So, and if you're not sure what to do, have a guess. I'm now going to multiply them out, just to check. 2 times x is 2x squared, those two. And then I've got minus 1 times 2x, which is minus 2x, plus 5 times x, minus 1 times 5. And 2 bits in the middle happily turn into 3x, which is what we wanted. Right. Now, I had fun making this, I really did, just for you. So, absolute beast. Let's just take time to appreciate why it is such a truly appalling beast. It's because of the numbers of factors, basically. 28, well, we're okay with 28, aren't we? Because 28 is, in fact, 1 times 28, 2 times 14, 4 times 7. So, 24, we did that before. 1 times 24, 2 times 12, 3 times 8, 4 times 6. And you can see why this lends itself to a bit of a problem, because the contents of these 2 brackets, that's about the only thing we know. The first 2 numbers, there and there, could be any one of those 3 pairs, and the second numbers could be any one of those 4 pairs, but the order matters, so there's actually 8 possible ways around we could do them, and that's even before we get to the signs. So, there is a quicker way to do that, this question. It's not very nice, you're not going to like it. You can either start having a little guess, and there are some people who can quickly find their way towards a solution doing this. But I'm not even going to bother. I'm just going to go for my method that works on all of these, and it starts by multiplying the 28, the number in front of the x squared, with the constant at the end. So I do 28 times 24, which gets me, let me just think for a moment, 672. Yep. Now, I'm now after the factors of 672. So I know that this is made by those two, and I want a pair of factors for this that will get me 11. Okay. So, because I've actually got a negative 24, and it's minus 672, so one of the factors is going to be negative. Now, there's quite a few factors of 672, 14 times 48, for example, or 42 times 16, but the pair we want is 21 times 32, because 21 and 32 are 11 different. And now I'm going to start using this little method. Now, the 11x I'm going to break down into two terms, and I'm going to have a plus 32x and a minus 21x. Okay, and those two things make 11x. If you simplify those, you get 11. Where did I get the numbers from? I got them from over here. Why did I pick those? Because the difference is 11, and they're factors of 672, which came from the two outside numbers. The minus 24 stays where it is, like that, and so does the 28x squared. Now, I've got two bits here. The first two terms, I'm going to factorise that. 28 and 32 are both in the 4 times table, and they've both got an x. 28x squared is 4x times 7x, and 32x is 4x times positive 8. Now, over here, the two numbers are both in the 3 times table. So, minus 3, and then 7x, and plus 8. Positive because minus 3 times positive 8 is minus 24. So that's why it's not a minus there. Now you know you're on the right track when these two brackets have the same thing in it, because that's one of our brackets, and the other bracket comes from these two things. 4x minus 3. So 4x minus 3, 7x plus 8. And of course, being a suspicious mathematician, you would multiply it to check. So 4x times 7x is 28x squared. 4x times 8 is plus 32x. Minus 3 times 7x is minus 21x. And minus 3 times 8 is minus 24. And you can already see that I've got back to where I was here, and that's going to give me plus 11x there. That is the quick way to do it. I think there's another video on my YouTube channel that explains this in perhaps a little more detail. Please don't be intimidated by my seeming swiftness with my arithmetic here. I did it on a piece of paper first, and I used prime numbers, the prime number decomposition like I did here, to figure out the right pair of factors. Also worth saying that something like this is very unlikely to be seen in any examination, certainly any that I've ever looked at, because examiners aren't really interested in seeing if can you factorise truly repulsive things. But that said, it's a useful method to know, because if you need it, then you know you can break even the most repulsive quadratic. Hope this was useful.